Hello, this is me, Sami Sabir Hamid Ahmed Thabit, and today I'm going to do the tech presentation of my project, which is crack detection in concrete image using image processing techniques. So before I start, I'd like to give a short brief about my project. As we know that concrete surface contains noise such as stains and shading in several sizes. So it is difficult to distinguish image with noise by conventional method. The idea behind developing a crack detection system is to provide an effective maintenance system where cracks can be detected and analyzed with greater accuracy. The proposed project could release engineers from the tiring and repetitive and time-consuming job, which the latter had to face during the earlier days. With the help of machine vision and crack detection algorithms, the inspection of cracks on pavements and bridges would be made autonomously, and a higher degree of accuracy is expected from vision-based system. And that was the answer of the given question in the slide. So crack detection is important for the inspection, then for the diagnosis, and finally for the maintenance of the concrete structure. The simulation results were done in MATLAB software, and the first algorithm tested was offline algorithm, where simple image crack was tested on the Simulink program. The original was taken from Google Images, and the original image resolution was 194 times 259 pixels. The image was then converted to grayscale image using RGB to intensity block function. From histogram, it can be observed most of the image grayscale colors are between 150 to 255, and very minimal colors are from the range 0 to 150. And therefore, it indicates that most of the crack pixels are between the 0 to 150 range, and those that form the background range between 150 to 255. And the filtered image and its histogram after using the median filter with the default configuration, as it can be observed, median filter causing smoothing of the image. But however, it's difficult to point out the differences between the first histogram and the second one. The crack image results after the passing through the auto threshold block. It can be observed that the shape of the crack is detected. However, it is still not counted as one blob since there are many holes in the crack. The crack image after the dilation process, here the dilation with the diamond structural shape and radius 12 was applied comparing comparing the dilated image to the previous image. So the holes are completely filled up, and the crack is now considered as one line. However, the shape has been deformed, has become thicker. Thus, some further morphological operation was required. And the final results, as we can see for the crack image, with the bounding enclosing the crack, the color for the bounding box is green as it is mentioned, and the crack length is displayed on a display unit from Simulink library. And now, now, as we can see the slide of sustainability and development, it means the project is sustainable and developed, and the proposed system would be socially equitable, as in ensuring that surfaces remain in good condition, and thus providing a safe journey for the passengers. Crack inspection is preventive maintenance done to determine the actual conditions of the surfaces. The estimated cost for implementing the system is relatively cheaper compared to the cost invested by maintenance companies for inspecting structures. And here, most of the materials and components used are available at low cost. The maximum amount spent in implementing the project is around 3,000 ringgit. All the components and materials proposed in implementing the prototype are non-hazardous one, and represent no danger to the environment. So finally, I can say that the proposed enhanced crack detection algorithm and evolution could help maintain the safety and lifetime of the structures under inspection, and at the same time, the help relieve engineers from tiring and repetitive work. Thank you.